Now question number 32. Number of positive integers n for which n square plus 96 is a perfect square is n square plus 96 must be a perfect square. How many such possible values of n exist? The first option A is 1, second option B is 2, third option C is 3, fourth option D is 4. Let us now observe. What is the thing actually required? We require n square plus 96 is a perfect square, isn't it? Perfect square. Let n square plus 96 is equal to m square. Say, as it is a perfect square, there is no sin in assuming this to be some m square. From this, what can you have? N square minus m square is equal to 96. Implies n minus m into n plus m is equal to 96. N minus m into n plus m is equal to 96. So, as in minus m is less than n plus m, here we observe that both n minus m and n plus m must be even because the product is even. If one of them is odd, if both are even, we are supposed to get 96. Well, how many possibilities are there? N minus m is equal to 2, n minus m is equal to 4, n minus m is equal to 6, n minus m is equal to 8, like that. If n minus m is 2, then n plus m is 48. If n minus m is 4, then n plus m is 4. If n minus m is 6, n plus m is 16. If n minus m is 8, then n plus m is 12. With these, how can you get? N plus m is 48, n minus m is 2. You add them, you are getting 2n is equal to 50, so n is equal to 25. N is equal to 25 means m is equal to 23. Here, you add these two. 2n is equal to 28, so n is equal to 14. N is equal to 14 means m is equal to 10. Is equal to 10. Here what happens? 16 plus 6 is 22. So 2n is 22. So n is 11. N is 11. So m is, what is m? 11 plus 5 is 16. At the last case, if you add these two, 2n is 20. So n is 10. N is 10 and m is therefore 2. Therefore, the possible combinations of n and m are 25, 23, 14, 10, 11, 5, 10, 2. That's all. If you proceed further, m may become negative. So, these are the 4 options. So, what are the possible values of n? 4 possible values of n are there to get n square plus 96 as a perfect square. What is the right option? Option D is the right option. Fourth option is the correct answer. The next question before us is question number 33. The question is, if alpha, beta are the roots of x square plus px minus q is equal to 0 and gamma, delta are the roots of x square plus px plus r is equal to 0 such that q plus r is not equal to 0, then alpha minus gamma into alpha minus delta by beta minus gamma into beta minus delta is equal to. First option is 1, second option, that is option B, is 2. Option C is 3. Option D is none. Let us see. What are the equations given? This is question number 33, of course. The first equation is x square plus px minus q is equal to 0 with roots. What are the roots? Alpha, comma, beta. And the second equation is x square plus px plus r is equal to 0 with roots. What are the roots here? Gamma and delta. From this, what can you have? alpha plus beta is equal to minus p is equal to gamma plus delta. Gamma plus delta is minus p and alpha plus beta is also minus p. Alpha beta is equal to minus q and gamma delta is equal to r. And gamma delta is equal to r. This is the information that you can gather. Well, let us now think of the requirement. What has been asked? We want to have alpha minus gamma into alpha minus delta by beta minus gamma into beta minus delta. This is the question. Let us first concentrate on the numerator. What is numerator? Alpha minus gamma into alpha minus delta. You multiply these two quantities, alpha into alpha, alpha square, alpha into delta, gamma, alpha into delta, alpha into gamma. So minus alpha into gamma plus delta plus gamma delta plus gamma delta. This is equal to what is gamma plus delta? In the place of gamma plus delta, you can write minus p plus gamma delta. What is gamma delta? It is r. Here is the beautiful equation alpha square plus p alpha. Alpha is a root of x square plus px minus q is equal to 0. Isn't it? Therefore, alpha is a root of the first equation. Let me call this equation 1. Implies alpha square plus p alpha minus q is equal to 0, or alpha square plus p alpha is equal to q. In the place of alpha square plus p alpha, you can write q, that is q plus r. Successfully, we have got the value of the numerator alpha minus gamma into gamma minus delta, and it is q plus r. Absolutely in the similar fashion, it is not difficult to get the value of the denominator also, that is beta minus gamma into beta minus delta, and it is easy to observe that it is also q plus r. As both of them are equal to q plus r, so the required ratio is q plus r by q plus r. What does it give? It gives us 1. Option A is the right answer. This is about the question. The next question is question number 34. In this question, we have given a lengthier equation, a polynomial equation of degree 99. Let us see. 2 into x power 99 plus 3 into x power 98 plus 2 into x power 97 plus 3 into x power 96 plus and so on, etc. 2x plus 3 is equal to 0. Number of real roots he requires. Let us see. What is the options are? Option A, only 1 root. Option B, 2 real roots. Option C, 3 real roots. Option D, no real roots. Let us examine the given equation. What is the given equation? The problem is question number 34. Question number 34. And the given equation is 2 into x power 99 plus 3 into x power 98 plus 2 into x power 97 plus 3 into x power 96. Next, again 2 into plus 3 into 2 into 3 into, like that. If you go on, 2x plus 3 is equal to 0. Let me do one thing. Let me take 2x as a common factor. What are you going to have? X power 98, x power 96, x power 94 plus 1. 3 as a common factor. 3 into x power 98 plus x power 96 plus x power 94 and so on, etc. 1 is equal to 0. In these two, this big bracket comes out as a common factor, leaving you 2x plus 3 into x power 98 plus x power 96 plus x power 94 plus and so on plus 1 is equal to 0. You now observe the term inside the big brackets is a geometric progression, with common ratio x square. How many terms are here? See, x power 0, x square, etc., x power 4 and so on, etc., up to x power 98. All are even numbers below 100. How many such even numbers will be there in the exponents? 50. How many terms are here? 50 terms are here. Therefore, this is 2x plus 3 into, let us recall the formula for sum to n terms of a GP. Here the common ratio is x square. What is the answer? This is 1. Let us come from that one. 1 into, what is the ratio? X square. X square power 50 minus 1 by x square minus 1 is equal to 0. So that 2x plus 3 into x power 100 minus 1 by x square minus 1 is equal to 0. By looking at this equation, one can easily notice that the possible roots are, one is minus 3 by 2 and the other are plus or minus 1. Similarly, plus 1 and minus 1, they cannot satisfy the equation. So plus or minus 1 is not possible. Therefore, the only possible root here is 2x plus 3 is equal to, if at all the 2x plus 3 is equal to 0, then what happens? X is equal to minus 3 by 2 is the only possible real root of the equation. How many real roots are here? Only one real root, that is the first option, that is option A is correct. Now let us notice question number 35. That is the next question. Question number 35. What is asked here? If the roots of the equation x cube minus ax square plus 14x minus 8 is equal to 0 are all real and positive, then the minimum value of integral part of a is, where that symbol square bracket a involved in the square brackets can also be read as greatest integer less than or equal to a. As there are 4 options. The first option is 3, option B is 4, option C is 5 and option D is 6. Let us observe the equation. What is the given equation? X cube minus ax square plus 14x minus 8 is equal to 0. Let me call this equation 1. Let alpha, beta, gamma be the roots of 1. Implies, what is the sum of the roots? Alpha plus beta plus gamma is equal to a, and alpha beta plus beta gamma plus gamma alpha, this is equal to 14, and alpha beta gamma is equal to 8. Well, what do you want actually? A, that is alpha plus beta plus gamma. Alpha plus beta plus gamma, sum of the roots. It is involved in arithmetic mean of the roots also. Moreover, here an important and useful information has been given. The roots are all positive. As they are all positive, we can consider their geometric mean also if needed. And if you think that it helps you, you can consider them. Now, let me use the famous result regarding arithmetic mean and geometric mean of the roots. AM is greater than or equal to GM. Provided the numbers are positive, here of course the roots are positive, we are going to apply this one for alpha, beta, gamma. Yes, what is AM? Alpha plus beta plus gamma by 3. What is GM? Alpha into beta into gamma whole to the power of 1 by 3. What is alpha plus beta plus gamma? A by 3 is greater than or equal to, what is alpha beta gamma? 8 power 1 by 3. We know that 8 power 1 by 3 is 2. Therefore, a by 3 is greater than or equal to 2, or a is greater than or equal to 6. A is greater than or equal to 6. Therefore, the minimum value of a is 6. Hence, minimum value of integral part of a is also 6. Minimum value of integral part of a is 6. And is it available in the options? Yes, it is available in the fourth option, that is option D. We have 6 as the answer. Hence, minimum value of integral part of a is equal to 6. So, option D is correct. Option D is correct. That is the question. We now look at the next question, that is question number 36. He is asking us to find the remainder when 2 plus 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus etc. 10 into 10 factorial is divided by 11 factorial. The remainder when the so-called big number has been divided by 11 factorial, we want to have option A is 1, option B is 2, option C is 3, option D is none. Let us observe the given number. What is the given number? The question is question number 36. The given number is 2 plus 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus 4 into 4 factorial plus 10 into 10 factorial. I have taken this 1 into 1 factorial. Actually, that 1 is not given and it is not a sin to have that 1 there. This is equal to 2 plus sigma r into r factorial. R is equal to 1 to 10. Let it be like this only. Don't touch it. Come here. R into r factorial. This can be taken as r plus 1 minus 1 into r factorial. Any problem? I have added 1 and subtracted 1. So that what is going to happen? R plus 1 into r factorial is r plus 1 factorial minus 1 into r factorial, r factorial. Therefore, this can again be taken as sigma r plus 1 factorial minus r factorial. R is equal to 1 to 10. Let us expand this. 2 plus, if r is 1, what happens? 1 plus 1, 2 factorial minus 1 factorial. Next, 3 factorial minus 2 factorial. Next, 4 factorial minus 3 factorial. Next, 5 factorial minus 4 factorial. At last, 11 factorial minus 10 factorial. Let us see what is going to happen. 2 factorial cancelled. 3 factorial cancelled. 4 factorial cancelled. You observe the first term of a bracket is going to be cancelled with the second term of next bracket. Second term of next bracket. Like that, all these will be cancelled. 11 factorial will not be cancelled because there is no bracket after this. Just like that, minus 1 is not cancelled because there is no bracket before this. Altogether, this is 2 minus 1 factorial is minus 1 plus 11 factorial. At last, what are you going to get? 11 factorial plus 1. It's very, very simple. If this number is divided by 11 factorial, what remains here? 1. That is, the remainder is 1. The first option A is the right option. What is the remainder? 1. The next question is x, y and z are positive numbers and x into 1 minus y is greater than 1 by 4, y into 1 minus z is greater than 1 by 4, z into 1 minus x is also greater than 1 by 4. Then the number of ordered triplets x, y, z satisfying the above inequalities is R. First option, that is option A, is 1, only one triplet. Second option, that is option B, is 2. There are 2 triplets. Third option is 3. Fourth option is 0. That is, there might be no triplets at all satisfying that inequalities. Let us check it. Question number is 37. X, Y, Z are all positive. X into 1 minus Y is greater than 1 by 4. Y into 1 minus Z is greater than 1 by 4. Z into 1 minus X is also greater than 1 by 4. He has given. Let us multiply all these three. What is going to happen? X, Y, Z into 1 minus X into 1 minus Y into 1 minus Z is greater than 1 by 64. Let us keep it at a side. Let us first observe t into 1 minus t. What is the fate of that expression? What is t into 1 minus t? That is t minus t square. That is minus of t square minus t. That is minus of t square minus t plus 1 by 4 plus 1 by 4. Am I right? So this is 1 by 4 minus t square minus t plus 1 by 4 is just nothing but t minus half whole square. Justly to make this as a perfect square only, I could have added and subtracted 1 by 4 here, so that we will be able to observe this as 1 by 4 minus t minus half whole square. But you see, t minus half whole square is a perfect square. That is a non-negative number. So this is less than or equal to 1 by 4. For any real t, t into 1 minus t is less than or equal to 1 by 4. Let me take x in the place of t. X into 1 minus x is less than or equal to 1 by 4. Y into 1 minus y is less than or equal to 1 by 4. Z into 1 minus z is also less than or equal to 1 by 4. As in the previous case, if you could multiply all these three inequalities, let us see what is going to happen. X into y into z is x, y, z, and 1 minus x into 1 minus y into 1 minus z is of course less than or equal to 1 by 64. You please observe these two inequalities. These are purely contradictory. This says that this product is greater than 1 by 64, and that says that the same product is less than or equal to 1 by 64. How is it possible? These are mutually contradictory statements. Therefore, you cannot have such triplets x, y, z satisfying the conditions in the data. So the number of triplets is 0. Such things will not be available at all. The fourth option is, that is option D is the right option. That is 0. Number of triplets is 0. That is about the question. The next question, that is 38th question, is before us. In this question we are given a cubic, not a quadratic. F of x is equal to 30 minus 2x minus x cube. Then find the number of positive integral values of x which satisfies f of x greater than f of minus x. Let us see. The actual function given is f of x is equal to 30 minus 2x minus x cube. This is the function. Find f dash x. Minus 2 minus 3x square is surely less than 0 for all x belongs to R, implies f is a decreasing function. F is a decreasing function. Decreasing function. This is going to become a strong weapon in our hands, because in the present question an inequality has been given connecting f. Let us make use of that. What is the inequality given? F of x. F of x is greater than f of minus x. Now, this is a decreasing function. Let me call this entire thing A, this B. F of A greater than f of B, but f is a decreasing function. What should happen? A must be less than B. That is f of x is less than f of minus x. Again, let us use the same concept. Let me now take this function, this number as a and this as b. F of a less than f of b, and f is a decreasing function. What should happen? A must be greater than b. That is, f of x is greater than minus x. What is f of x? 30 minus 2x minus x cube greater than minus x. Bring it here. 30 minus 2x plus x minus x cube greater than 0. Multiply that entirely with the minus sign. X cube plus x minus 30 less than 0. X cube plus x minus 30 is less than 0, and it is an easy matter to see that x is equal to 3 is satisfying the equation x cube plus x minus 30 is equal to 0. Therefore, x minus 3 will be a factor. To have the other factor, it is an easy method to have the synthetic division style like this. 3, 1, 3, 3, 9, 10, 30, 0. So from this, x minus 3 into x square plus 3x plus 10 less than 0. But you see, x square plus 3x plus 10, you observe the quadratic. The discriminant is less than 0 for that. Discriminant is less than 0 means this is strictly positive always. And to make this entire thing less than 0, what should we have? X minus 3 less than 0. That is x less than 3. X must be less than 3. Find the number of positive integral values of x which satisfies. What are the positive integral values less than 3? 1, 2. 1 and 2. Those are the only positive integral values of x which satisfies x less than 3. Therefore, x is equal to 1 or 2. Therefore, option B is the right option. Option B is the right option. The next question before us is question number 39. In this question, he is asking us the least positive integer x for which 2x minus 1 by 2x cube plus 3x squared plus x is positive is equal to. Option A is 2. Option B is 1, option C is 3, option D none. That is, actually we are not given the expression, we are given an inequality. What is that inequality? 2x minus 1 by 2x cube plus 3x square plus x. 2x cube plus 3x square plus x. That is 2x minus 1 by x into 2x square plus 3x plus 1. That is 2x minus 1 by x into 2x square plus 3x plus 1. This is equal to 2x minus 1 by x into x plus 1 into 2x plus 1. This is greater than 0 we must have. This greater than 0 we must have. This greater than 0 we must have. So, therefore, the requirement is this. Now, let us apply the scheme of signs for this expression. What are the actual roots for the numerator? Half, 0, for the denominator 0, minus 1 and minus half. Let us observe the scheme. What is the least number? Minus 1. Next, minus half. Next, 0. Next, 1 by 2. So the largest number is half. Here plus, minus, plus, minus plus. What do we want to have? Greater than 0. Greater than 0. Observe the regions in which x is greater than 0. So, x belongs to half to infinity union minus half to 0 union minus infinity to minus 1, because we should have a positive answer. Well, least positive integer x for which it is positive is equal to this minus half to 0 and half to, here half to infinity. This is the positive region. Half to infinity, how many positive integers will be there? Infinitely many positive integers will be there. Out of all those positive integers greater than half, what is the least positive integer? 1. That is, there is only 1. The least value of x is 1. How many the least positive integer is? 1. Option B is the right option. The next question before us is the largest negative integral value of x for which the inequality mod x square plus x minus 6 is less than 6 is satisfied. First option, that is option A, is minus 2, option B is minus 4, option C is minus 3, and option D none. Let us observe the inequality. This is the question number 40. The inequality given here is mod x square plus x minus 6 less than 6. If mod A is less than k, we know that minus k less than a less than k, that is a lies between minus k and k. By making use of that, here also we can be in a position to say that minus 6 is less than x square plus x minus 6 is less than 6. Here, two cases will arise. This is one case, this is another case. Let us first observe this. Minus 6 less than x square plus x minus 6 and x square plus x minus 6 is less than 6. What happens to this case? Minus 6 and minus 6 go away. 0 less than x square plus x. That is, x square plus x is greater than 0. That is, x into x plus 1 is greater than 0. By applying the sign scheme here, this is minus 1, 0, positive, negative, positive. Where should x lie? X belongs to minus infinity to minus 1 union 0 to infinity. 0 to infinity. Then only it will be positive. Okay, let us observe that one. X square plus x minus 12 less than 0. That is x plus 4 into x minus 3 less than 0. Now let us apply this scheme of signs for this. Minus 4, 3, plus, minus, plus. Do you want to have this less than 0 or greater than 0? Less than 0. So for this, x should lie between minus 4 and 3. Minus 4 and 3. Well, you observe these two. Minus infinity to minus 1 union 0 to 4 and x belongs to minus 4 to 3. Minus 4 to 3. What is the largest negative integer? What is the largest negative integer? Minus 4 to 3 if you proceed. Minus 4, minus 3, minus 2 to 3. Of course, this is 0 to up to minus 1. X belongs to here. Therefore, what is the largest integer? Minus 2. Hence, option A is the right option.